Hello, my name is Matthew Hevert, and I performed this lab alone as my lab partner was out after having to save a burning school bus full of grad students from being attacked by a horde of rabid comp questions. This lab covers Lab 2, Gaussian beam profiling and propagation, and the purpose of this lab was to explore the basics of Gaussian beams, profile a Gaussian beam, and look at how a beam propagates through a lens. We begin this by aligning the microscope to the laser beam, similar to how we did it in lab number 1. Once the microscope was aligned, we focused the crosshairs on the laser aperture and took note of the measurement on the rail. This provided us with an accurate location for the laser aperture surface. The microscope was set an arbitrary distance, roughly 50 centimeters back, and I placed the knife's edge, with its incredible and stunningly well-constructed mount, between the laser and the microscope. Focusing the microscope on the razor by moving the razor mount into best focus gave the true position of the razor, and this tells us the exact distance between the laser and the razor, which will be used in later calculations. With the knife edge in position, a photodiode is positioned right behind it so that power measurements can be recorded. I found by moving the X position of the micrometer in increments of about 30 microns, I was able to collect a good amount of data without going overboard on the measurements. This gives us a beam profile that we can then use to calculate the beam radius at that point. This is then done a second time with the knife edge in a different location so that two different beam profiles could be compared. We now introduce a 200mm lens about 400mm away from the laser, and we record its position. Again, we use the microscope to get an accurate location of the lens and then propagate the laser through both the lens and the microscope. This creates a special spot on the wall that interests us. We can roughly find the location of the beam waist by analyzing this spot on the wall and moving the microscope forward and backwards on the rail until we have found when the spot size is its smallest. This corresponds with the beam waist. I don't know why I keep saying we. Anyways, I then added the knife edge back into the system and recorded its position and placed the photodiode behind the razor in order to collect data that will tell us what the beam radius is, just like what we did in the previous part of the lab. Data was collected with a knife edge at an approximate location of the beam waist, and then the process of finding the beam waist was repeated with the knife edge placed at the new beam waist location. The measurements that were taken for the beam radius and for the recorded locations of the knife edge, lens, and laser aperture will be used to perform calculations to find the basic properties of a Gaussian beam. Thank you for watching. Good night.